Have you ever stopped to think about how huge, really complex projects get managed? Especially when you're talking cutting-edge tech like AI and, multiple government agencies involved.
Yeah.
It just seems almost impossible, right? Keeping everything aligned, moving forward without it all just falling apart.
It's a massive challenge. Absolutely.
Well, today, that's exactly what we're diving into. We're looking at America's AI Action Plan.
Right.
And specifically, this really fascinating idea at its core called meta-temporal coordination and feedback loops.
Sounds complicated.
It does.
Yeah,
So
yeah.
our mission here is to unpack what that actually means
Okay.
and, crucially, show you why it's so vital. Why something like national AI policy could genuinely descend into chaos without it.
You'd risk wasted resources, conflicting goals.
Exactly. Maybe even flawed AI systems out in the world.
That's right. The research we looked at really digs into how federal agencies handle this. It's about managing actions across time.
Across time.
Okay. And using real-time data to update policies, make sure everything from, say, a new rule to a training program is perfectly synchronized.
Like an orchestra conductor.
Kind of, yeah. An essential behind-the-scenes orchestration.
Okay, let's unpack this term then. Meta-temporal coordination. It definitely sounds technical. What is it, really? In plain language.
So, at its heart, it's about managing actions and information flow across different points in time.
Okay.
The goal is consistency and alignment within a big system. Imagine different government agencies, right?
Yeah.
They need to work together smoothly, even as things change, timelines shift. It's about creating coherence.
Coherence even when everything's moving.
Exactly, despite that constant motion and change.
That makes sense conceptually. But coherence across so many different groups. It sounds incredibly difficult. What are the practical ingredients, the principles that make it actually work?
Good question. The material breaks it down into a few core components.
Okay.
First, there's the temporal dimension, basically tracking when things happen, precisely. Knowing exactly when a new policy update kicks in everywhere, so everyone's on the same clock, literally.
Got it. What else?
Then there's versioning. This is all about recording changes over time.
Like saving different drafts.
Exactly like that. So you can see how things evolved. You have the latest version, or you can even go back if needed. The sources give a great example. NIST, that's the National Institute of Standards and Technology, their AI model evaluations constantly update the Department of Labor's training programs.
Oh.
Each update is a new, carefully tracked version.
I see. So temporal dimension versioning. What's next?
Concurrency control. Think of it like air traffic control for government actions.
Okay, preventing collisions.
Precisely.
Yeah.
You don't want two agencies making conflicting changes at the exact same time.
Right.
So this ensures different groups, maybe like the CAIO, the AI Interagency Council, synchronizing efforts, aren't overriding each other's work.
Makes sense.
And finally, consistency, making sure policies actually align across agencies.
So no one goes rogue.
Pretty much. Yeah. The GSA's, the General Services Administration's procurement toolbox is mentioned as an example of keeping purchasing policies consistent no matter who's doing the buying.
Okay, that's helpful. Temporal, versioning, concurrency, consistency. The research also uses this analogy of a supercharged Google Calendar.
Right, I like that one.
It helps visualize it, doesn't it? Each agency logs its actions, policy updates, whatever. And then feedback loops act like real-time notifications, adjusting the schedule when new data pops up. Why is that analogy so effective? How does it connect to using real-time data?
It works because it makes something abstract feel concrete. We all get shared calendars, right?
Yeah.
And notifications pinging us. It shows data isn't just sitting there. It's actively triggering change.
Ah, the trigger.
Yes. Those feedback loops are the dynamic part. New info comes in, maybe new evaluation, and the plan adapts.
So old policies don't just hang around.
Exactly. It makes the whole system living, responsive, not just static.
Okay, so we've got the concept and the principles. Let's bring it back to the really big picture. America's AI Action Plan. How does this coordination apply to something so huge?
Well, the federal agencies involved, like OSTP, the White House Office of Science and Technology Policy,
Okay.
and NIST and DOL, the Department of Labor, they aren't just talking about this stuff. They're actively using these coordination methods and feedback loops.
They're doing it now.
They are, to implement the AI Action Plan.
Yeah.
And the ultimate goal, which the research explores, is to analyze these processes, monitor them.
To improve them.
Exactly, to refine them, maybe break down complex coordination into smaller, reusable steps, or design better user interfaces to actually see how things are flowing.
Visualize the whole thing.
Right, or even build prototypes to simulate the coordination, test it out before rolling it out fully.
Okay. And the material mentions an AI team for this. Meta-AI, Lyra, TASe, Aurora, Kodax. That sounds like a sci-fi movie.
Huh. Yeah, it does a bit. But it's important to understand these aren't, actual people.
Right.
It's more of a framework. Think of them as specialized AI agents or functions.
Okay. Different AI tools working together.
Precisely. Each designed to tackle a piece of this massive coordination complexity.
And this is where it gets really interesting, I think. The research shows how the main orchestrating AI, Meta-AI, actually processes a request. And a request to analyze these coordination processes in the action plan. There's a structured planning phase.
Yes, it's very methodical.
It's not just, hey, figure this out. First, Meta-AI has to really understand the request, clarify the goals.
Crucial first step.
Then it breaks it down into specific manageable tasks. It's like a programmatic approach to this huge real-world challenge.
Very structured. It makes the complexity digestible, actionable.
Right. Can we make it even more tangible? You mentioned the NIST and DISEL example earlier.
Yes, the interactive tutoring scenario from the material. It's a great illustration.
Walk us through that.
Okay, so imagine NIST evaluates an AI model for bias.
A common task these days.
Very. And the results of that evaluation, they need to directly inform updates to the Department of Labor's training programs.
Okay, makes sense. Train people based on the latest findings.
Exactly. But that handoff isn't simple. It requires that meta-temporal coordination we've been talking about.
How so? What does it demand from the system?
Well, first, versioning. You have to track every evaluation change, like Git for code, with timestamps.
Okay, keep a history.
Essential. Then, concurrency control. What if NIST updates an evaluation at the exact moment DOL tries to update its training program based on the old evaluation?
Chaos. Conflicts.
Right. So you need things like digital locks or smart merging strategies to keep the data clean.
Right, okay.
And critically, feedback loops. It has to be automatic. NIST evaluation changes. DOL gets notified instantly.
Triggering the curriculum updates.
Yes. It's not someone sending an email weeks later. It's responsive.
That makes it much clearer.
And maybe think about it this way, for you listening. If you were building that system, tracking NIST evaluations and DL updates, how would you make sure both agencies see the latest data without stepping on each other's toes? What problems might pop up?
Yeah, that really puts the challenge in perspective. That NISTL scenario highlights the complexity.
It does.
And the research shows how those specialized AI function, the AI team, tackle these issues. Each has a specific role.
That's right. Very specific roles in visualizing and understanding the coordination.
So you have TASe, the Task-Agnostic Step Extractor?
Yes. CASE's job is to break down big goals, like coordinate federal agencies for the AI action plan into reusable abstract steps, focusing on that timing, the feedback loops.
The abstract steps, like building blocks.
Kind of. Reusable components for coordination.
Interesting. Then there's Aurora, the visionary designer.
Right. Aurora designs the user interfaces, clean, accessible ways to see the coordination flows.
Like dashboards or timelines.
Exactly. Timelines showing agency actions, OSDP's updates, NIST's evaluations with clear markers for the feedback loops, making it visible.
And Kodax builds these, the pragmatic front-end engineer.
Yep. Kodax takes Aurora's designs and implements them, builds a working prototype using web technologies, HTML, CSS, JavaScript.
So you can actually interact with the timeline, see the dynamic changes.
Precisely. Makes it viewable and interactive.
And overseeing this, Lyra, the prompt engineer. That sounds crucial.
Extremely. Lyra refines the instructions the prompts given to Aurora and Kodax.
Making sure they understand the goal correctly.
Exactly. Ensuring clarity, specificity, making sure everything aligns with the main objective of modeling the AI action plan's coordination.
Iterating until the instructions are perfect.
Optimized, yeah. So the output is exactly what's needed.
Wow. Okay, so pulling all these threads together, what's the big takeaway here for us, for the listener? Why is this structured meta-temporal approach so valuable?
I think the core insight is pretty clear. Meta-temporal coordination backed up by solid feedback loops and this very structured, almost programmatic approach.
Yeah.
It's the engine that can turn potential chaos into, well, a coordinated dance. especially for something as vast as national AI policy.
It brings harmony to all the moving parts.
Exactly. And ensures they adapt together in real time as new information comes in.
Right. This deep dive really drives home that it's not enough just to define policies.
No, definitely not.
You have to meticulously design the systems that make sure those policies get implemented and, importantly, adapted over time.
With clear roles, clear feedback.
Whether those roles are human or AI-driven, that constant feedback loop enabling adjustments.
That's the key.
So here's a final thought for you to mull over as we wrap up.
Yeah.
How could this highly structured, meta-temporal way of coordinating AI policy, how might that apply to other huge societal challenges? Interesting question. Think about global climate change initiatives, maybe large-scale public health responses like pandemics.
Complex systems with many actors, evolving data.
Exactly. What new challenges or maybe new opportunities might emerge if we tried applying this same rigorous framework more broadly?
A lot to think about there. How would that change our approach to those massive problems?
Definitely something to consider.